All right, hello. Welcome to my channel. We do educational stuff on this channel, and normally we work on theories of everything, particularly theories of everything that you've never heard about and that you probably won't ever hear about except for this channel. And today is our 220th video on Dewey B. Larson's reciprocal system of theory. And I could probably do a couple thousand videos on Larson's system, but hopefully I'll stop short of that and move into other subjects at a certain point. But right now we're kind of about to wrap up his 1979 book called Nothing But Motion. And Nothing But Motion is a good way to kind of summarize Larson's reciprocal system of theory in general. Larson posits that we live in a universe of motion. The universe is not made out of matter, it's not made out of energy, but it is made out of motion. Matter and energy are just two different kinds of motion, as are many of the other scientific phenomena that you're familiar with, such as pressure and acceleration, speed, matter and energy, electric current, electric charge, magnetic flux, electrical capacitance, density, and force, and fluidity, viscosity. These are all forms of motion. And what characterizes motion for Larson is that motion is the relationship between space and time. All of the aforementioned entities are basically fractions, where time or space is in the numerator and space or time is in the denominator. But in Larson's first postulate that he came out with in the 1950s, his first and primary main postulate, he postulates that space and time both have their coordinate aspects. Coordinate space, we're familiar with, 3 dimensions of space, but there also is coordinate time, 3 or more dimensions of time. And so that complicates things a little bit. And you can have quantities such as matter, time to the 3rd power over space to the 3rd power, resistance, time to the 2nd power over space to the 3rd power, permeability, time to the 3rd power over space to the 4th power. You have things like acceleration, time over space to the 2nd, or space over time to the 2nd power, or force, time over space to the 2nd power. Energy is simply time over space. And as we probably know, speed is space over time. The bicycle is moving at 15 miles per hour. 15 miles of space in 1 hour of time. And so it is very convenient to be able to have these space and time only components of all of our favorite scientific quantities. Makes it very easy, a lot more easy than the MKS system, because that's meter, kilogram, second. Well, meter and kilogram, meter and second are time and space, but the kilogram is matter, time to the 3rd power over space to the 3rd power. And that kind of follows everything up. We can just get rid of that, and then you just have the MS system, or really just the reciprocal system. Another aspect of Larson's postulates is that space and time both have their clock aspects. We're familiar with clock time. The time is always getting later and later and later, but in no particular direction. This is what Larson calls a scalar motion, a motion that has a magnitude but has no particular direction. And that is the flow or the progression of space, of time. But there is also the flow or progression of space. Larson calls that clock space. space is always getting farther and farther and farther apart. And we perceive that in the Hubble telescope. Looking through it, we can see that all of the distant galaxies are moving away from each other. That is the flow of space, which you can model with a balloon and a magic marker. And if you put some dots on the balloon and blow up the balloon, all of the dots are moving away from each other. The further away they are, the faster they are moving away from each other. You can also use something like raisin bread for this, if you want to add in that dimension of the interior of it. All of the raisins are moving away from each other as you bake the bread. Now, another aspect of the first postulate is that space and time both come in only discrete units. There's a minimum unit of space and a minimum unit of time. They're very small, but they exist, and so you can't get less than 1 unit of space or time. Inside of 1 unit of space or time, you don't have space and you don't have time, respectively. Now, exactly one unit of space in 1 unit of time, again, that's space over time, or speed. 1 unit of space in 1 unit of time is the speed of light. So the speed of light for Larson is really 1. He calls it unit speed. And it divides our universe in half, more or less. There is a half of the universe that is moving slower than the speed of light, that Larson calls the material sector, and that we are familiar with, and our scientists are familiar with through their observations and measurements. But there is another half of the universe that is actually moving faster than the speed of light, which Larson calls the cosmic sector. And this sector of the universe is virtually unknown, evidenced by what Einstein said, where the speed of light is the maximum speed of the universe, whereas Larson says it is the midpoint of the universe. That's because Einstein didn't know anything about the faster than speed of light part of the universe. And part of the universe is on top of us, but we just don't perceive it. We're not able to really see in time. We only really see in space. And so you can see here in the material sector, you basically have what is called coordinate space, 3 dimensions of space, and clock time. And in order to extrapolate that information over to the cosmic sector, you simply reverse the roles of space and time. That's the general nature of reciprocity, or the reciprocal system. And so in the cosmic sector, you have 3 dimensions of time and or coordinate time and clock space, progressing space. So those are unfamiliar to us, but that is what is dictated by the reciprocal system. And then, when you're trying to form matter, you're really atoms. You're really dealing inside a unit of space over in the material sector. And over in the cosmic sector, you're dealing inside a unit of time. Inside a unit of space, you don't have space because of the discrete unit postulate. You only have time. And so in this realm of less than a unit of space, which is where the atom is formed, you have what Larson calls the time region. And in the same way, over here, where you're talking about cosmic matter, or what the legacy scientists call antimatter, you have inside a unit of time, there is no time, there's only space. So that's called the space region. This is all pretty elegantly mapped out by the Tajitu, if that's how you pronounce it, from Chinese Taoism, the yin-yang diagram with the squiggly line between two sectors and they both have dots within them, that is a good representation of Larson's universe. And that squiggly line is the speed of light. Okay, now we are about to wrap up this chapter here, which is called Simple Compounds, in chapter 18 of Nothing But Motion. And after this, I think I'm just going to summarize a little bit about the remaining 3 or 4 chapters, and then look at a little bit at the other 2 books that are in this trilogy, or a 3-volume work called The Structure of the Physical Universe. There is Nothing But Motion. Then the second book is called Basic Properties of Matter. Third book is called The Universe of Motion. And we will eventually go over those other books, but they're even a little bit more advanced than this. And so I'd like to lay a little bit of groundwork and maybe move into some other material, still on the reciprocal system, but by some other authors, and just a little bit more perspective. So let me take over here, or let Larson take over here, for the last couple paragraphs of this chapter on simple compounds. Another point that should be noted here is that when hydrogen acts in a positive capacity, it does so as a division 3 element, not as a member of division 1. Its +1 valence is therefore magnetic. That is why hydrogen was assigned only to the negative position in the revised periodic table, rather than giving it 2 positions as has been customary. The variation in negativity with the size of the magnetic displacement has the effect of extending the division 3 behavior into division 4 to a limited extent in the higher groups. Lead, for example, has practically no division 4 characteristics, and bismuth has less than its counterparts in the lower groups. At the lower end of the atomic series, this situation is reversed, and the division 4 characteristics extend into division 3 as an alternative to the normal positive behavior of some of the elements of that division. Silicon, for instance, not only forms combinations such as manganese, silicon, and cobalt silicon 3, which on the basis of the information currently available appear to be intermetallic compounds similar to those of the higher division 3 elements, but also combinations such as magnesium 2 silicon and calcium silicon 2, which are probably true compounds analogous to beryllium 2 carbon and calcium dicarbon. Carbon carries this trend still farther and forms carbides with a wide variety of positive components. In the 2A group, the division 4 characteristics extend to the 5th element, boron. This is the only case in which the 5th element of a series has division 4 properties, and the behavior of boron in the compound formation is correspondingly unique. In its division 1 capacity, as the positive component in compounds such as B, boron 2, oxygen 3, boron is entirely normal, but its first order negative valence would be -5. Formation of compounds based on this -5 valence conflicts with the previously stated limitation of the negative valence to a maximum of 4 units. Boron therefore shifts to an enhanced negative valence, adding 2 positive units to its first order value of -5, with a resultant of -3. The direct combinations of boron with positive elements have such structures as iron boron, Feb, and copper 3 boron 2. However, many of the borides have complex structures in which the effective valences are not as clearly indicated. This raises a question as to whether boron may be an exception to the rule, limiting the maximum negative valence to -4, and may utilize both the -5 and -3 valences. This issue will be considered in the next chapter. Okay, and that is the end of this chapter. The next chapter is called Complex Compounds. And I just think that we probably want to postpone going into this chapter until there's little bit more foundation laid and people are more comfortable with this, including me. This is a lot of organic chemistry, I believe, and it's important stuff, but it's just that it's a little bit off the track of trying to introduce people to the reciprocal system. I do want to, provide Larson's own words and to be able to present the system in some kind of depth, but this is probably a little bit too deep for us right now. The chapter 19, complex compounds, and then I believe there's also a chapter here on ring compounds. I'm having a little bit of trouble scrolling. This chapter is extremely long as well. So that's kind of what I think. If anybody has a complaint about that and they want to get into this right away, more power to you. Now, I'm trying to get to the next chapter here, but the next book in this trilogy is called Basic Properties of Matter. And Basic Properties of Matter is primarily on chemistry. And, kind of this is a little bit strange because this chapter here is on organic chemistry, and you would think that you would need a little bit of regular chemistry before you get into the organic chemistry. But so the book Basic Properties of Matter starts with chapters on compressibility, interatomic distances, which is establishment within the time region of an equilibrium. Because in the time region and in the space region, the roles are reversed from what they are in the material and cosmic sector, respectively. And so in the material sector, you have the force of gravity, which brings everything closer together. And then in the cosmic sector, or you have the force of gravity, which brings things closer together, and then you also have the what Larson calls the progression of the natural reference system, which is basically anti-gravity, although it's primary to gravity. So really, gravity is kind of like anti-progression, actually. But the progression of the natural reference system is really the flow of space. It brings everything, moves everything farther and farther away. But if you cross into the time region, then the roles are reversed, and gravity actually moves everything away from each other out toward the boundary of what Larson calls the unit space boundary, out to the quantum level of space within the time region. And the progression actually moves everything closer and closer together. So Mainstream science is usually looking toward gravity as the force that brings everything closer together. But within the atom, it's actually the opposite. It's the progression that causes things like solid cohesion. Okay, so now if you're looking at Larson's book here, volume 2 of The Structure of the Physical Universe, Basic Properties of Matter, I'm just going to read the chapters here for you. Chapter 1, Solid Cohesion. Chapter 2, Interatomic Distances. Chapter 3, Distances in Compounds. Chapter 4, Compressibility. 5, Heat. 6, Specific heat patterns. 7, Temperature relations. 8, Thermal expansion. 9, Electric currents. 10, Electrical resistance. 11, Thermoelectric properties. 12, Scalar motion. 13, Electric charges. 14, the basic forces. 15, electrical storage. 16, induction of charges. 17, ionization. 18, the retreat from reality. 19, magnetostatics. 20, magnetic quantities and units. 21, electromagnetism. 22, charges in motion. 23, magnetic materials. 24, isotopes. 25, radioactivity. 26, atom building. 27, mass and energy. Okay, so that is what Basic Properties of Matter is about, and it's actually a great book. It's very, very difficult, obviously. You know, any type of book on chemistry is pretty difficult, so don't blame Larson for everything there. But it's also introducing a lot of new and unfamiliar concepts. We will be getting into this book before long. But for right now, I think we're going to move back and study a few other authors that are also talking about the reciprocal system of theory. And we'll get into that starting tomorrow. So thanks for tuning in. Have a great day.